I have an interactive activity for you to do with Mathematica that will really help reinforce the concepts about limits that we have studied in this unit. You will want to download and print out this worksheet. As you work through the Mathematica Notebook, there's things that you'll need to fill in on the worksheet. There's places for you to individually answer some questions, as well as a chart to complete. For each one of the 4 cases, you're going to answer some questions. Complete the sketch with key values like C and L, epsilon and delta. Where do they go on the graph? What would the general sketch look like? To complete the entire worksheet, you'll go through all 4 cases. There's 2 separate pages for this, and at the very end, I'd like you to make some notes about what you learned by doing this activity and any observations that you made. I'll show you a couple things about the Mathematica Notebook and how it works as well. When you download and open the Mathematica file, it should look something like this. You'll be able to open the individual sections with these down arrows. So if I click on this, you might get something that looks like this because I've already evaluated the code. So you need to click Enable Dynamics in the upper right corner, and then the graph should appear. If the graph looks hidden, you can grab this corner with the little dots and drag this around so that it fits. So what we have here is the graph of a situation where we have the limit as x approaches c of f of x equals L, a finite limit when x is approaching a finite value. So follow the directions carefully on the worksheet. What you'll first do is take this red dot and you can drag it around to the location specified. I believe it goes to 4, 3. Now if you can't get it exactly there and you can see the exact values up here in red, you can hold down the Alt key while you drag and it'll drag it more slowly. So you can work to try to get it as precise as possible. You can move the epsilon bars by grabbing this green dot and moving this up and down. The value of epsilon will be listed here. You can grab the orange bars, and we have here a separate delta 1 and a separate delta 2. So when you adjust those, you will see the values for delta 1 and delta 2. There's places for you to fill those in on the worksheet in the chart. And of course, you'll have to pick one delta that works in both directions. When you start getting things closer and closer to the point, you may want to zoom in. So I built in a magnification tool here. And you can use the scroll bars, or depending on the size of your monitor, you can grab this and expand things out so that you can see closer and closer to the point as you try to get more accurate values. You don't have to be 100% precise, but you try to think about what these values mean and figure out values that are reasonable and as close as you can. This one will take the longest because it's a little bit more complicated. But once you have the idea, then you'll work with a vertical asymptote, a horizontal asymptote, and our case where we have an infinite limit at infinity.